Okay, so in the cyclic part, the interval is more than 1 year. Like you can see an example of recession and inflammation. So when we have a recession, so we can see the economy is going down, and if then the inflation, the price is going up, and similarly it goes on. And another few years, if there is again a recession, so it's again go down. So you can see the time period of this is greater than 1 year. So we'll call it a cyclic. So basically, seasonal and cyclic repetition, you will see some same pattern, but if the length of the pattern is less than 1 year, it's seasonal. If greater than 1 year, so we will call it a cyclic. And random is something that is unpredictable. We the time series component that is obtained after these three patterns have been extracted out of the series is the random component. Means we can't predict. Like I have given you example of the gold prices. So you know there are some today it's high, yesterday is low. There's some random changes which we can't predict. So this is an example of this is random part. We can't predict. Overall, it's a trend. Like you can see in the gold price, there is a trend as well as a random factor. So time series can be a mixture of all the four components or two components, three components, and anything like that. Like I will give you an example. Like in this slide, you can see the first image. It have a increasing trend. Like you can see overall the graph is going up. Like you can see a orange line in between. So you can see it's going up. Overall, it's a have a increasing trend. But you can see it have a seasonal pattern. As you can see, the same pattern is coming again and again and again. So this is a seasonal as well as it have a increasing trend. So time series can be including the trend part, seasonal part, and random part. So in the second image, you can see downward sloping curve. So it's a decreasing trend, as well as you can see it's not basically increase. Sometimes it's increasing. So it's a overall it's decreasing. So it's a decreasing trend with some random parts. You can see it's a mixture. Yeah. So we have covered the components of time series. Now, yeah, we this is increasing trend, and the second image there is no trend at all. This is random something. Yeah, uh, this is for better understanding. Like same graph can have both increasing as well as uh, means trend is over a long run, not a short run. So like if you can say like in a random like in the third image you can see it's all random, but you can say for a short run it's increasing and then decreasing. Will it be a trend? No, it will not be a trend. It's for a long run. Like in the first you can see 2001, 2003, 2005 it's increasing, then suddenly it's going down. So for a long run it's a trend, but in the third image you can't say, and in the second image you can't say. Like even for a like will it be a trend? No, it will not be a trend. Like it's increasing, suddenly decreasing. So it will not be a trend. Like today it's increasing, then decreasing, then increasing. It's a random or something like that. It's not a trend. Trend is over a long period. And then like imagine we have removed the trend and it's only have the seasonality. So you have the second graph, and third is the random part after we remove all the time series or trend part, seasonality part, or the cyclic part. Yeah. This is the idea behind the univariate time model. You can just, we will share the slides of, I think we haven't shared the slides of the first session. So we'll share the first session slides and the second share slide. You can read, it's nothing uh, important or more valuable. So you can just read, it's simple. Uh, yeah, this is the application you can see like used by the Joel Merchant to forecast gold or silver prices or forecasting inflation rate or unemployment rate and weather forecasting, something like that. So you can see the application. We will share it. Now we will come to the main part, like what are the different time series model. So first is white noise process. So like I think Previously, I have given you the example like YT, YT1, YT2, YT3. It's just simply the notation like we are putting like at the point T, what is the data point? Okay. So what is white noise process? If a series is purely random in nature, it is called white noise process. So white noise is completely like a random part, you can say. Like simply nothing is said. Each day, each data point, each time there is some random, or we will uh, denote it as epsilon t. Epsilon t, matlab, epsilon t means data at time period t. It's epsilon t. The t is represented as a subscript. We will write below the epsilon means epsilon, and below near its leg we will write a small t. So it's epsilon t. But in the computer we have it's written like epsilon t, but it's epsilon with subscript t. So it's that data point at the time period t. So let epsilon t denotes such a series, then we assume that as it's completely random, so we'll assume like it's comes from a normal distribution that we have discussed in our first session. So we will assume like it will have a zero mean, and it have constant variation sigma square. So what does that mean? Like mean zero, like always it will vary around zero. If you can say like if there's a time says we have some error part, so sometimes it's positive, sometimes it's negative. So overall, if we take an average, like we take an easy assumption, why we call something a random? It's going up and down. Like it's there's no like it's if it always showing a plus, then nothing random. If it's going plus negative, something like that, it's completely random. So its mean will be zero, and it have some constant variation sigma square, and it's uncorrelated. Like uncorrelated means there is no relation. Like we have given the formula in the previous session, and we have shared the videos. So if you don't know what is the correlation, you can watch those videos to have better understanding the what is the exact formula. But in simple sense, there is no relation between the epsilon t and epsilon s. S means another time point t, which we called it as s. Means at one time period is denoted as t, and another time period is denoted as s. So like in whiteness, we are saying everything is random. So there is no relation between epsilon t and epsilon s. So you say like if you say a two time period t, let let I assume 10 and 11, mean, or 10 or 15. These are just two time period, like day 10 and day 15. If I will try to have some correlation, then it will be zero. There will be no correlation as everything is random. So I hope you have understand the avoidance. So simply in summary, it's completely random. It have mean zero. Like what the series will be looks like epsilon t plus one, epsilon t plus two, epsilon t plus three, and just go on. So it will have mean zero. If you take any point, it overall it have mean zero and constant variation sigma squared, and the series is uncorrelated. Now we have another model. This is AR model. So we have also shared the videos of individual models, white noise, AR model, and then we will discuss moving average, MA model, and ARMA model. So you can watch for the better understanding. Like we have just giving an introduction here. So in detail, you have to watch the videos to get how that uh, data is going on, or how the it's going on. We are just giving a simple proof, or simple proof means simple idea. What is this? Now, second model, we will have auto-regressive model. So we have some data sets, YT minus one, YT minus two, YT minus three, and so on. So what is AR model? AR model is but in which YT depends only on its past values. YT minus one, YT minus two, YT minus three, etc. We will call it ARP process. Means you can see the common representation of AR model where it depends on P of its past values called ARP models represented as ARP means YT depends on T previous its values like YT depends on YT minus 1, YT minus 2, YT minus 3 up to YT minus P plus there is some random part that is epsilon T. So and there's some constant associated with the uh, past like how much it depends on YT minus 1 which is denoted as beta 1, beta 2, beta 3. So I think you can understand like it's YT. You can imagine Y as T as subscript of Y. So in computer we have some difficulty in making slides, so we will just write in the platform, but it's YT is equal to beta 0. Beta 0 is some constant, and then beta 1 YT minus 1, then beta 2 YT minus 2. This is means YT minus 2 is the past past value means you can see we are predicting the model. If you we have given the values past p events, then we are assuming that yt will be this. We are and if we have some if we have yt also, then we can predict yt plus 1 also. What will be yt plus 1? You can see the formula. It will be the beta 0 plus beta 1 yt plus beta 2 yt minus 1, beta 3 yt minus 2, and go on. And the last random part will be epsilon t plus 1. So this is ARP means the YT will depend on last P past values. This is ARP. So ARP autoregressive model. We in short we write as ARP model. Yeah. Next we will have a moving average value in which the model depends on errors in the it in this the error propagates means like MA model is one when YT depends only on the random error terms which follows a whiteness process. Like YT will be a function of epsilon t minus 1, epsilon t minus 2, epsilon t minus 3. So it's the past error terms means epsilon t is dependent on epsilon t minus 1, epsilon t minus 2, epsilon t minus 3. So if we say a model is MAQ model, you can see MA bracket Q. It means YT depends on the Q errors terms, and this you can represent as YT is beta naught plus epsilon T plus phi 1 epsilon T minus 1 plus phi 2 epsilon. There is some mistake in the representation, but it's phi times epsilon T minus 2 plus phi 3 epsilon T minus 3 up to Q order. Like it's M a Q process, so its last term will be phi Q epsilon T minus Q. So this is the how the process in the model will go. Is the moving average model. Then we have auto-regressive moving average model. In short, it is also known as ARMA model, ARMA model. So we will represent as ARMA PQ process, where P represent the AR part and Q represent the MA part order. So ARMA is a mixture of both AR part and the MA part. And the order of AR part is P and order of MA part is Q. So you can understand by your own how we can represent YT. YT can be represented as beta naught plus beta 1 YT minus 1 plus beta 2 YT minus 2 up to beta P YT minus V. As you can see, this is the AR part. Okay, like you can understand, we have understood like it's ARP process, mixture of ARP and MAQ process. So we have written the ARP process. Now we will write the MAQ process. It's epsilon T plus phi 1 epsilon T minus 1 plus epsilon oh it's phi 1 epsilon T minus 1, phi 2 epsilon T minus 2, ep- and phi 3 epsilon T minus 3, and go on up to epsilon Q epsilon phi Q epsilon T minus Q. You can see it. Uh, you you can watch the videos for more understanding. We are just giving a small introduction. So now we will discuss the stationarity of time series. So basically, there's a term called strictly stationarity, but you guys will not use it as much. It's not more useful. You will the more useful term will be the covariance stationary or weakly stationary. So you will mainly in the if you do any something research in the time series or take a course, you will mainly use the covariance stationary thing. So what is the covariance stationary? There it has some condition which if the time series follow this condition, then we will call that series to be covariance stationary. So what are those conditions? So these are the conditions. So you know what is E? E means expectation value. It's a kind of mean. So expectation of y1, y2, y3 up to yt should be mu, means a constant. It should not be going like y1 has some another constant, y2 has another mean, y3 has another mean. It's going on. It's all the expectation value of y1, y2, y3 will be mu. And similarly, variance y1, y2, y3 should be a constant. You can denote as a y or sigma square, but it's a constant mainly. Its mean is constant and its variance is constant. And the third and the another important condition, it's covariance. Covariance means if you try to find covariance between two uh, two different data points like yt and yt1 and yt2. So it doesn't depend on T1 and T2, but it should depend on difference between T1 and T2. Means if you have a point, like example, one point is YT, another is YT plus 3. So it should depend on only on 3. Means it should be same for T plus 3. Covariance of YT and YT plus 3 is equal to covariance of YT1 plus 3 and YT1. Means T1 you can see like 1 minute. I will be more precise. Like you have two things, T1 and T1 plus 3. So this is two things, and another is T2 and T2 plus 3. These two, these both these two terms will have same covariance. So it depends on the difference between you. It doesn't depend on T1. It doesn't depend on T2. It depends on the difference. T1 and another is T1 plus 3. So it's the difference is 3. So it depends only on 3, not the T1. Similarly, when we see it's T2 and T2 plus 3, it depends on 3. Both have same covariance. If you try to calculate covariance of T1 and T1 plus 3, it will be equal to the covariance of YT2 and YT2 plus 3. So it only depend on difference. So like you can see like covariance of Y1, Y1 plus K is equal to covariance of y2 y2 plus k. So you can see the difference between these is k. So covariance will be related on the difference between the two time series. So this is the three condition which will if these three condition will follow, so you will call it a covariance stationary process. So we have shared stationary video on the Discord, so you can watch it, have a better understanding. So, so this is the three condition which will be which our series called. Then it is called a stationary. Basically, it's covariance stationary. Strictly stationary is something else which you don't require. But we have written something. If you want, you can Google or you can see the YouTube videos to have better understanding. But we don't use much. Yeah. Now, if these conditions are not followed, the series is called non-stationary. But there are some series which can be made stationary after referencing. Like we have a series like yt minus 1, yt minus 2, yt minus 3. And similarly, what is differencing? Take we take difference of consecutive terms. Like we say, we will call an another time series xt is equal to yt minus yt minus 1. So what does that mean? We are differencing the yt and yt minus 1. So but xt terms will be y, but will be the terms of times is xt. Xt will be look like first xt is equal to yt minus 1. What will be the term xt minus 1? Xt minus 1 term will be yt minus 1 minus yt minus 2. And similarly, what will be the x t minus 3 term? It will be y t minus 3 minus y t minus 4 term. I hope you are understanding. It's just a bit of notation like t minus 2, t minus 3. So you can watch video if you are not understanding. If we have some blackboard, I think I can explain more better, but hope so. We have now less than 1 minute because it's only 40-minute session. So yeah, the if we have after differencing one time, it's becoming stationary. We will call it as integrated of order one. If after d times differencing, it's becoming a stationary, we will call it at integrated of order d. So yeah, this is a basic introduction. In the next class, we will cover the doubts we you have in the week 3, and we will also share an assignments. So if someone has not given attendance and present in the session, you can DM DM me or Aditya. We will mark your attendance. We know that some more people have joined, so we will